Welcome back, folks. Mr. Callen here to help you with solving division equations. Here we go. Hey, if you need to check some homework answers, go ahead and check this for assignment number 12. Pause, come on back when you're ready. Make sure you bring some questions to me, folks. I don't really know what's going on with 41. I apologize, I didn't look at that. We will come back if you have any questions on that. Focus for today, as it has been on the previous educational day, I will use algebra to solve one-step equations. Now, we've done multiplication of fractions, decimals, so now we're finding equations with division fractions or multiplication decimals, and of course, moving into more complicated multi-step equations as time goes by. Just wanted you to know where we were, where we are, and where we are heading. So here we go, name date period, if you're working on this on the 9th or the 8th of September. We're going to cross off some problems for today. Instead of 25 all the way to 42, let's just do 25 to 36 all, as well as 6 to 20 evens. Go ahead and press pause, title your paper, come on back when you're ready. And let's go with some examples. So you are welcome to draw a line under here and write EX, for example, if you wish. Let's go. Hey, some examples of division equations. We've done equations with addition, with subtraction, with multiplication. Let's go with division. The very first thing I want to point out, though, is what an equation like this means. So let's just picture a full circle, right? So we want to know how much is in the total envelope of money. What we know, though, instead of knowing the total envelope of money, is we have precisely a third of it. Now, some of you already got great number sense computation skills. You're realizing, hey, what we need to do is keep splitting that up and put that in and find the total amount. So how do we show that with algebra steps? Because you know it's going to get tougher, right? So here's what we got. We have an envelope of money split into 3 parts, $12. What would one whole envelope be? Well, what we need to do, as you might imagine, the inverse of division is multiplication. And of course, anything we do to one side, we do to the other. Now think about what we just did, ladies and gents. What we just did is say, hey, 3/3 of the envelope is precisely what? One whole envelope. Think about the picture. 3/3 gives me the entire circle. Meanwhile, excuse me, 12 is only 1/3 of it. So we're going to need 12, and that's the same size. We're going to need 12 here. That would be the 3 12s. And so we can see that 12 times 3, 36. There's our solution. Let's go ahead and check it. Take your equation, substitute in the, substitute in, let me make this a little smaller here. Substitute in what you think is the answer. I'm going to put a little question mark here. Cover up that side. All right, folks, we're going to get this right. There we go. 36 split into 3 parts is 12, and hey, that looks like a true statement. So let's follow along with the next problem. T over 5 is equal to 40. But I don't want to know what a fifth of t is. I want to know what one whole t is. So let's take this t over 5 and multiply it in 5 parts. Again, being fair to both sides. Now remember what that means. That 5/5 gives me one whole. Yep, you guessed it. I'm going to stop writing that 1 in. While 5 sets of 40 is none other than 200. Now we go ahead and we check our equation, substituting in what we think we know. We don't think that t is unknown. We think that t is 200. But let's go ahead and make sure that's a true statement. 200 divided into 5 parts is 40. And hey, looks true to me. Carrying on with example number 3, I'm going to make this a little bigger for us, a little more space. C split into 10 parts, so imagine what that looks like. Each of those slices being 1 6/10. But we don't want to know what a tenth of C is, we want to know what C is. So we go ahead and we start filling this in, right? So instead of a tenth of C, let's take 10 parts of that. And then, of course, be fair to both sides. After all, each of those 10 parts is going to have 1 6/10 inside. All right, what do we got? A tenth of 10, or should I say 10 tenths, is 1 whole. I'm not going to write the 1 whole this time. And then 10 times 1 6/10. Now use your mental math skills here, ladies and gents. Simply move the decimal place 1 to the right to find it to be 16. Don't believe it? Well, check this out. Substitute it in. And in this case, when you use your mental math skills and we are dividing by a power of 10, we're going to move the decimal place to the left. And we get 1 6/10, which, hey, is the same as 1 6/10. So that's a true statement. And we wrap it up with the last problem. Now this is interesting though, because we're splitting it into tiny, tiny parts, but we don't want the tiny parts, we want the whole thing. So let's get rid of those tiny, tiny parts. What is the inverse of division? We're going to multiply here, as long as we are fair to both sides. And in this case, 2/10 divided by 2/10 equals 1. I'm going to go ahead and erase the 1 though. 4/3 times 2/10, multiplying off to the side. You might use your mental math skills here. After all, 2 43s is 86 with 1, 2 decimal places. But something seems complicated about this, so you know what? I am most certainly going to check. Let's take our solution, substitute it in, split it up into 2/10, and see if this is in fact a true statement. Now remember to divide decimals. We take the decimal of the divisor and turn it into a whole number as long as we are fair to the dividend. I'm going to come off to the side. I'm going to go ahead and divide 8 6/10 by 2 wholes. Putting my decimal point up. And look at there. So we end up with 4 3/10 is in fact the same. That is a true statement, and it works. So imagine all those problems. Look at all those problems, please. How are they similar? How are they different? Well, start with the similarities. They all have division in them. They all have division on one side and a number on the other. To get rid of division, we use multiplication. Why does that work? Why does that cross out? Remember, with addition, you'd have something like x plus 2 minus 2, and it would cross out because it makes 0. Here, it crosses out because it makes 1. After all, 3/3 makes 1 whole, 10/10 makes 1 whole, 5/5 makes 1 whole, and so on. We also see the problem, the work, the solution, and the check for every problem. So I want you guys really focused on how are the problems similar, how are they different. Pause if you need to, rewind, go back, watch something else. Let me know if you have any questions. And back to the homework. Don't forget, you might have examples right here. Remember, write those directions down, even if the directions are as simple as solve and check. Then go into number 6 and write the problem, your work, your solution or answer, and then don't forget, with algebra, I'm going to ask you to show that check step as well. All right, folks, take time, do well, and let's grow.